Hello there, this is General Mahendra Popat. We are discussing Geotechnical Engineering Soil Classification. This is video part 3. In previous two videos, we have seen why we should classify the soil, how we should classify the soil, as well as field classification of the soil and different soil classification systems. Let us go further now. Group Index. It is denoted as GI. The Highway Research Board (HRB) classification system, also known as Public Road Administration Classification, or we can call PRA, is based on the particle size composition as well as the plasticity characteristics. It is also known as AASHTO, AASHTO, AASHTO. Full form is American Association of State Highway and Transportation Official. This system is useful for classifying soils for highways. In this system, the soils are divided into 7 primary groups designated as A1 to A7. A characteristic group index GI is used to describe the performance of the soil when used for pavement construction. Group index is not used to place a soil in particular group. It is actually a means of rating the value of a soil as a subgrade material within its own group. The higher the value of group index, the poorer is the quality of material. GA is used for rating fine-grained soils for their suitability as a highway material. The group index of a soil depends upon the amount of material passing through 75 micron ISU as well as liquid limit and plastic limit of the soil. Formula for GI group index value is 0.2 in bracket F minus 35 plus 0.005 in bracket F minus 35 bracket over again in bracket WL minus 40 bracket over plus 0.01 F minus 15 into in bracket IP minus 10 bracket over. Here what is F, WL and IP? So we know the terms as F is equal to percentage by mass or soil fraction passing through ISU of 75 micron. WL, that is liquid limit, and IP is plasticity index. All these three things we have studied in previous videos. Now for shortening the formula, F minus 35 is defined as small a, F minus 15 is defined as small b, WL minus 40 is defined as small c, and IP minus 10 is defined as small d. So the formula becomes 0.2 small a plus 0.005 AC, both the things are small, plus 0.01 BD small. Here GA value is generally in the range of 0 to 20. Please note that maximum value of A and B can be 40 and maximum value of C and D can be 20. So F minus 35 and WL minus 40 as well as F minus 15 and IP minus 10 should be maximum this, not greater than this. Group index is, in simple terms, it is a special value which decides the application of the soil in road subgrades. Let us go further in the numericals. Problem 1. A fine-grained soil sample has liquid limit 60% and plastic limit of 18%. Classify the soil. As usual practice, we will write given data first. So in given data, WL is equal to 60% and WP, plastic limit, is equal to 18%. I'll find plasticity index first, as WL and WP are there. My IP value, plasticity index, will be 42%. From problem, I know that fine grained soil is there. That is why I should use IS plasticity chart, A line chart, which was studied in earlier video. So equation for IP is equal to 0.73 in bracket WL minus 20. Putting WL value here, I will get IP value as 29.2. My A line IP value is 29.2, where my actual soil IP value is 42%. So 42% is greater than 29.2. It is above A line. So the given soil is CH, clay with high plasticity. It could be silt or organic soil, but due to its liquid limit greater than 50% as 60%, we have to go with clay with high plasticity. Let us go to the next numerical. Problem 2. The following data is taken from 5 soil samples and classify the soil. Here liquid limit and plastic limit are given. This is sample 1, sample 2, sample 3, sample 4 and sample 5. Let us calculate IP A line value if it is above IP A line, if it is below IP A line, and then define the type of soil. So if the liquid limit is 25% and plastic limit is 15%, IP will be 10%. If IP is 10%, A line IP is equal to 0.73 in bracket WL minus 20 will be 3.65 after calculation. Now it is clearly above IP A line value, as 3.65 is much lesser than 10. So it is above A line, where its water content, liquid limit of this is 25%, which is lesser than 35%. So it is CL, clay with low plasticity. In second case, liquid limit is 45%, plastic limit is 23%. So IP value comes as 22, and A line value in that case is 18.25. Again, IP value is greater than the A line value, so it will be above A line, and the liquid limit is in between 35 to 50. That is why I have to take CI, that is clay with intermediate plasticity. In the third type of soil, it is 50. Liquid limit is 50% and plastic limit is 25%. So IP comes as 25% and A line value comes as 21.9. Again, it is clear that it is above A line and value is exactly 50%. So I have to assume this as CI or CH, as it is on the edge. It may be clay with intermediate plasticity or clay with high plasticity. In next case, liquid limit is 60%, plastic limit is 35%, and IP comes as 25, where A line value is 29.2. So it will be below A line. Sorry for this misprint, it is below A line. As it is below A line, it will be MH or OH as silt with high plasticity or organic soil with high plasticity. It is high plasticity due to liquid limit greater than 50%. In last case, liquid limit is 80%, plastic limit is 36, so IP comes as 44%. A line value will be 43.8. So again, it will be above A line, and it is having liquid limit more than 50% and above A line, so it will be CH, clay with high plasticity. Let us go to next problem. Problem statement is percentage passing from 4.75 mm ISCF is 64, percentage passing from 75 micron ISCF is 6. Uniformity coefficient is 7.5, coefficient of curvature CC is 2.7, plasticity index is given as 2.5, let's classify the soil. So, as per IS classification, percentage passing through 75 micron ISU is 6%. It is lesser than 50%. So, soil is coarse grained soil. Now, passing through 4.75 percentage 4.75 mm ISU is 64%, which is greater than 50%. So, I have to take soil as sand. So, it is coarse grained soil as well as sand. Then Cu value is showing greater than 6, which is 7.5, which is greater than 6, and Cc value, it is between 1 to 3 as 2.7. So soil will be SW, well graded sand, according to ISCS, which we have learnt in previous video. Moving forward to the next problem, find out the group index for the soil with percentage passing 75 micron ISCU is equal to 70% and liquid limit is equal to 50% and plastic limit is equal to 24%. As our practice, let us write given data. F is equal to 70%, WL is equal to 50%, WP is equal to 24%, and GI is to be found out. Here, let us find out A, B, C and D first, and then we will go to GI value. A is equal to F minus 35. Here F is given as 70. So A comes as 35. B is F minus 15. So 70 minus 15, it is 55. But maximum value of B is restricted to 40. C is equal to WL minus 40. So C comes as 10. And D, IP minus 10, which is WL minus WP minus 10. So it is 50 minus 24 minus 10. It is 16. So all three values are under limit, but B value is greater than 40. So I have to take B as 40 only. Let us put all the values in group index equation. GI is equal to 0.2A plus 0.005 AC plus 0.01 BD. This equation is taken from previous videos. So putting A, B, C, D values into this, GI comes as 15.15. You know very well that the higher the value of the group index, the poorer is the quality of material. Okay, so I conclude my video here. Soil classification topic is over here. Thank you.